hydroxide, which is what? OH minus. Good. Does that make sense? And why those two things, we'll actually learn later in this course. You'll get a little bit more of an insight into why the pH scale starts at 7, all kinds of things. We're not going to worry about that today. But what we are going to worry about is that it is an acid. Carboxylic acids are organic acids. And the way it happens is if you have a carbon here, and it's making a double bond to an oxygen, and that's also making a bond to an OH group. And then this could be to anything. For now, I'm going to do the simplest possible one, which would just be with an H there. But the chain could continue. Does that make sense? You could have 10 carbons over there. Now, this actually has how many hydrogens on it? Two. But of course, every alkane is full of carbons stuck to hydrogens, right? But when you dissolve this in water, I mean, first of all, it doesn't dissolve in water, but does it release that hydrogen? No. And even the ones that do dissolve in water, alcohols and aldehydes, they don't release any hydrogens. They're not acids. Here, which hydrogen do you suppose this thing is going to release when we dissolve it in water? Yeah, and not the whole OH, just this hydrogen here. Now, why? Why all of a sudden do we have a molecule? So this hydrogen is the acidic hydrogen, which means that it can be released. Why all of a sudden do we have one?
Because it's reactive with oxygen. And it's a negative.
What do we know about oxygen on the periodic table? Sorry? It's abundant. Hydrogen's the most abundant. But I want to focus on oxygen for a minute. Because how many oxygens are involved here and that's stuck to this carbon?
2.
Yeah, this carbon's making a double bond to this oxygen, and then it's making a single bond to another oxygen. So it's making 3 of its 4 bonds to oxygen. Does that make sense? But we know about oxygen that it has a fairly high what? Electronegativity. In fact, oxygen has the highest electronegativity of any element that can make more than 1 bond. What's more electronegative than oxygen? Chlorine, fluorine, but they can only make 1 bond. But oxygen's really interesting because it's highly electronegative, but it also can make more than 1 bond, which puts it in a unique position. And this OH group by itself is a polar bond, right? We call that hydrogen bonding. But it's not quite enough to make it ionic. Does that make sense? An ionic bond is when it straight up takes the electron, right? A covalent bond is when they share. A polar covalent bond is when they share unequally. But what happens is, if you take this same OH group and now you put another oxygen up here, now this oxygen actually contributes to this dipole as well. This oxygen is electronegative enough that it puts additional strain on the electron on that hydrogen. Does that make sense? And if you have this as a solid, that's okay. It just means it's a little bit more polar. But when you dissolve it in water, now you've got this pull on the electrons in this direction, and all of a sudden you also have water over here, which has a negatively charged side. And what can happen is that this hydrogen can get kind of induced, attracted to some of this water, and just get pulled right off, and the acid is able to take its electron for itself, because you have the high electronegative center of these 2 oxygens. Does that make sense? So just an alcohol group isn't enough to make that happen, but in an acid it is. So if we dissolve it in water, what can happen is that we end up with we end up with a negatively charged, and in fact we usually show the negative charge right on this oxygen because that's where it's stolen the electron, and then we have the hydrogen ion right here. And we have those 2 things together. Does that make sense? The acidic hydrogen gets released. Now, could this be inside of a chain? Could we do this on carbon 3 of a pentane? What do you think? Does it have to be terminal? Beautiful. Yeah, perfect answer. This setup, this carboxylic acid requires how many bonds?
3.
1, 2, 3. So it can only go on the end of a chain. It can only be terminal. Very good. That was an excellent answer, guys. So how do we name them? Well, we drop the E from the alkane and we replace it with oic acid. So this simplest one here would be what? If this was just a one-carbon chain, we'd call it methane. So this will be known as methan. We'd only drop the E. Methanoic acid. Good. All right. I want you to draw ethanoic acid for me. Draw me ethanoic acid. And don't use the skeleton just yet. Draw me a proper full structure with hydrogens and everything for ethanoic acid. Somebody thinks they got it and they want to go up and draw it. Feel free. Toby, you're looking eager. Yeah, get up there.
Oh, it vibrates.
Yeah, haptic feedback. It helps it feel like there's friction against the screen, even though there's not.
I don't like it.
I'm sorry. Sorry, I didn't build it, Toby. I don't know what to tell you. You can turn that off, but I do like it. That's lovely. Oh, that's great. I think you did a lovely job. How'd Toby do?
Very large.
Okay, how did Toby know to do 2 carbons? Ethane means 2. Very good. I'm going to shrink that a wee tiny bit, just so I don't feel like I'm being crowded out. That looks great. Very good. All right, now all the usual rules apply. What's our primary chain here?
1, 2, 3.
Ah, very good. Very good. Very sneaky. 1, 2, 3, 4, 5. Yeah. So what is our main chain? It's a pentane. All right. What functional group is this? What functional group's that? Yeah, right. It's a hydroxyl and an aldehyde, and we have a hydroxyl and an aldehyde on the same carbon. We call that carboxylic acid, right? So that means we drop the E, and instead we're going to call it oic acid, right? And then what's this? 3-methyl. Good. Sorry? I'm sorry. Yeah, sorry. Yeah, carboxylic acid, sometimes you'll see it shortened just to carboxyl group. Not in the name, but just sort of in describing it. So what's this name altogether? Close, but remember, what gets dropped? Just the E, so 3-methyl pentanoic acid. Very good. 3-methyl pentanoic. That's okay. Wasn't a criticism. Fun fact, Kate, did you know that oic acids existed 7 minutes ago? No, you're allowed to get the name wrong. It's okay. Settle down.
No,
You're good.
you can't get the name wrong.
You're good. It's okay.
I don't like that.
What don't you like? I respect that. Sometimes.
Japanese honeybees.
Okay.
Oh.
I'll phone up Jim at IUPAC. Be like, Jim, it's Joe from Eastdale. Kiki, I was talking with Kiki. Not happy with your. I was at. Can I tell you? This is a true story. I worked with. I didn't work with. I went to high school with this lady. She was wonderful. Her name was Leah. She was so funny, and she works at the Tim Hortons near my house. And she's got the sharpest sense of humor in the world. So I was in there once, and I was at the counter inside, and she was talking with me, but she was on the drive-through thing, and so I only heard her side of the conversation, but she told me later what the guy said. But this guy pulled up, and she asked if he wanted wanted an extra hash brown for 99 cents or something, I don't know. And the guy was like, oh, why do you always have to ask that? Like, come every day to ask a minute. And she was like, oh, sure, sir, just give me a minute. I'll phone up Tim, my buddy Tim Horton, and let him know that you find it annoying when we ask about the hash browns. And then she proceeded to go like, hi, Tim, it's Leah from St. Catharines, yeah. Yeah, this guy in the drive-thru finds it really annoying. And she did this whole thing, right over the drive-thru mic. And I was very impressed. I thought I would. It's not really good customer service, but it was really funny.
Is it supposed to be all one word, or is acid separate?
So in this case, I know we've said they're always all one word. In this case, they're two separate words. Acid is its own thing, because otherwise that would be really jumbly. I know these are jumbly to begin with, but that would be very jumbly. Don't do that. All right. Japanese honeybees are attracted to a compound that is released by the orchid Cymbidium floribundum. You could name your kid that too if you want. Cymbidium floribundum Mencken. It's got a ring to it. Got a ring to it. Anyway, biology students, what's wrong about that? Or, yeah, good. So let's fix that. English students, what's wrong with that? That hurt my feelings, but we'll ignore it. English students, what's wrong with the sentence? Very good. Lacking punctuation. All right, there we go. Fixed.
Aren't you the one who created this?
Yeah.
Wow.
I make mistakes. I'm allowed. You also make mistakes.
No, I'm perfect. What happened to your 400 to 1 ratio of mistakes?
Like how many I make to how many you make?
Yeah.
I think I'm living up to my promise. Okay, so draw this for me. 3-hydroxyoctanoic acid. Nice straightforward one. You can do it. And when you think you have a good answer, wait 45 seconds, wait a minute, and then come put it up here for me. 3-hydroxyoctanoic acid.
1, 2, 3, 4. You already asked, Miss Girl. I do not know. What's hydroxy?
What's on that? You got notes? And make a womp womp sound. You have notes. You can look it up.
Oh,
Yeah.
oh, I know what that is.
The Ontario.
I don't know that would mean that 1, 2, 3, and is hydroxide. I hate Tim Hortons.
Sorry?
I said I hate them. I don't want to talk about it. I think I figured it out.
Oh, there's one little mistake there. It's real small, but it's real important. No, yeah, I mean, we dissolve it in water, but no. Look at the other structures and look at yours. Look at your acids. Problems with your acid. It's small, but it's a key detail. Can carbon make a single bond to oxygen? Does that make sense? Otherwise, very good. You gonna draw this? Yeah, sure.
Oh, it's there. Okay.
Almost. The only thing is.
Ooh. Me? A little bit. 3, 4, 5, 6, 7. Is there only 7? 8.
We want that to be on carbon 8. Do you know what I mean? Where do we want the acid? It's going to be on carbon
I don't want to draw all these H's. I really don't like this pen. This pen. No, it just did.
Yeah, good job, Charlie.
I don't like that. That's too much attention. Don't mind my handwriting, guys. I suck. That's not even an H.
Oh, Charlie, I have my keyboard.
Okay. Taxes?
Oh yeah, I also have mine.
You know what? You should hire me at your no frills. Just do it. Just do it.
I pay you in Starbucks.
What'd you say, Kayla? Pay you her in Starbucks? Don't mind my horrible handwriting, please. Why is that H so close? I know I need to erase that.
What H is so close? I don't understand.
Well, that's not the same color.
Oh my goodness. Oh, it looks beautiful.
The H was very, very far away.
No, close to it.
Yeah, it probably is coming differently. You'll hit radical. Yeah. But yeah, nobody, especially in these science courses, you have to be judicious because if you hit every single piece of the curriculum, it's easy to then end up with a course where you do like almost no labs or something like that. And like I think it's important to try and mix it up. This looks good to me. How many carbons do we have? 1, 2, 3, 4, 5, 6, 7, 8. Is that an octane? Yeah, and then octanoic acid means we have the acid group, which is a double bond to oxygen and a bond to OH.
You're novel.
Bless you. Thank you. And finally, what is this doing here? What is that? Isn't that another alcohol? So why isn't this called octanoic octan 3-ol oic acid? I guess it could be, but
Because when you have, like, the acid takes near priority with the ending, so if you have an alcohol group anywhere else, it becomes a hydroxyl group.
that was a great answer. Wow. Even like naming priority is exactly the verbiage we'd use. That's great. That's right. This is the most important functional group of this. This is going to give it its primary characteristic. It's an acid. That's a big piece of functionality, right? So we call this an acid. And then, yes, it also has an alcohol group, but that is a less important feature. So we name it as a substituent or as like a side chain instead of naming it as the primary thing. That's good. All right. I'm going to give you some time to practice, but I did want to do one little stoichiometry question. Let's do some stoichiometry. Let's not forget. And I even did solutions here. So let's remind ourselves. I just want to remember, and again, I didn't teach most of you, so I don't know how Elastruck approached this. I'm sure better is probably the answer, but you're stuck with me now. So, but in chemistry, what's our kind of central unit? What's the primary unit we tend to work in, which bridges the small little microscopic unit of, and far beyond microscopic, the tiny, tiny nature of atoms and the macroscopic universe we live in is moles. Okay, and what letter do we use to talk about how many moles of something we have? N. N is how many moles we have of something. And so whatever we're talking about, N tells me how many moles I have of it. That's an important bridge because N is just a really big counting number, right? Does anyone remember how big a counting number? If I actually want to know how many things of A's I had, what's the relationship there? Which is? Yeah, very good. What she said was like my academic, that was my answer every time. That's a 3. Yeah, can't you tell? Can't you tell? It's so beautifully neat. How's that? Is that better? I'm glad to have your approval. And what's it branch us to? It lets us work with counting numbers, which is important because chemical reactions are recipes, right? They're based on counting things out. But they let us work. We can't count atoms out, but what can we do with materials? We can weigh them. We can measure their mass, and that's measured in grams. And what's the relationship between that? How many grams are in a mole? Where do we find that?
Periodic table.
Yeah, we look at the periodic table. But then once we know that, we can do a chemical reaction, right? Because if I know how many moles of A I started off with, I could know how many moles of B I'm going to end up with, or I could know how many moles of something I'm going to also need in my reaction, my recipe. This is what stoichiometry is, going from talking about one thing to talking about something else in a chemical reaction. How do I know the relationship there? What do I look at? I look at the balanced chemical equation, right? And then once I know how much B I have, well, then I can do the same trick, right? I can also figure out how many grams of B I should expect to get. All I would have to look at is the periodic table, because it tells me how many grams are in a mole, right? But then we can even go a step further than that. What if I take that and I make a solution out of it, an aqueous solution? What's that mean? Yeah, I can dissolve it in water, right? Well, if I do that, I could actually figure out the volume of my solution, right? In liters. Yeah, that's true. If we're going to do dilution, absolutely. If I want to go from moles of something to volume of solution, what do I need to know? I need to know how many moles are in a liter. What do we call that? The concentration. By the way, I could actually calculate the concentration instead if I wanted to. Though what would I have to know? I'd have to know the volume, right? Does that make sense? And of course, we can do that down here as well. We can also from here figure out the volume that we have of solution if we know the concentration. Fun fact, we don't measure volume in moles. Or we could figure out the concentration of the solution of B in moles of B per liter if we knew the volume, right? If we know the volume, we can find the concentration. And if we know the concentration, we can find the volume, right? Yeah, I don't use the equations. You can. Don't get me wrong, I'm not criticizing that. I really have never believed there's any reason to learn any equations in chemistry. Not in this stuff. Sometimes it's easier. Dilutions, sure, C1V1, C2V2, that's easier. So easy to remember, it rolls off the tongue. PV equals nRT, that rolls off the tongue. So sure, we'll use those as equations. All the stoichiometry, all that stuff, it's just so much more intuitive to work dimensionally, to work with dimensional analysis. And that's how Olastruck taught it as well, right? He taught dimensional analysis. I'm not like throwing you new stuff here. You're multiplying by fractions. Cool. So let's now remember that. We can go look at that roadmap here because what are we doing here? Do you remember stoichiometry? Sure you do. No, you don't. That's false. You're telling yourself lies. So organic acids react with bases just like any other acid you've learned about. By the way, that's a total lie, but it's kind of true. So for right now, we're going to pretend it's true. So let's do a reaction. How many grams of propanoic acid would be required to neutralize a 0.5 liter solution of 0.75 molar sodium hydroxide? We'll do this one together, all right? But tomorrow I'll give you a bit more practice. That we won't do together. I want to just remind us. First of all, I want to talk a little bit about this big M. What's big M mean?
Mass.
No, it means molar mass if I'm saying what is the molar mass of sodium. Yeah, then we go look it up. But as a unit, what does it mean? Concentration, measured in what?
Molarity.
Moles
Per liter.
Moles per liter, right? So that's a good thing to remember. Now, the first thing, and why this is a new thing, what is this?
That's 3 carbons with an acid on the end.
Okay, so carbon, carbon, carbon. What's the acid?
The double bond to O and the single bond to OH.
Cool. And then how many hydrogens will this need?
2 and 3.
And 3, okay. What's the formula of this thing then? C3O2 H6. That's correct. You know, it's funny because how you'll actually see this more often, and you're going to hate this. Ready? What you'd often see is C3H and then 1, 2, 3, 4, 5. And I know that seems weird. And then OOH, which I know is awful, but they use that and that sort of shorthand that we know it's a carboxylic acid. They're both correct. But if you ever see this and you're like, why wouldn't they call it H6 and O2? You will see this sometimes, and that's a shorthand for you to quickly see that you're talking about a carboxylic acid. You don't have to worry about that for now, but I just thought I'd mention it. What are we reacting this with?
NaOH.
NaOH. I guess that is its own formula. What's that going to yield us? What are we going to get? Well, remember, we said actually, where is this? Is it really on there? As soon as we dissolve it in water, where's that? It's floating free, right? So this is all just a spectator, actually. And are these actually stuck together? Nah, they're just... Sodium's also just a spectator. So we're going to end up with that sodium by itself, right? We're going to end up with the rest of this by itself, the C3O2. But is it still going to have 6 hydrogens? It'll only have how many now? 5, right? So we're going to have that. We're going to have the sodium by itself. But what will this hydrogen and that hydroxide do? Acid-base neutralization. They're all the same. What do they all form? They all form water, right? The H from the acid and the OH from the base form H2O. That is not a grade 12 concept, by the way. That's a grade 11 concept. You know your acid-base reactions, right? Hopefully. Now, you always did them with inorganic acid, so yours were always like phosphoric acid or sulfuric acid or hydrochloric acid or hydrofluoric acid. But it's the same process, right? The acidic hydrogen reacts with the OH and it gives us water. I don't actually care about that. What I care about is that we have a solution. How big's the solution?
0.500 liters.
What's in the solution already? NaOH. How much of it? Well, I don't know. 0.75 moles for every liter. Now, we don't have a liter, but that's fine. And what are we doing? We are sprinkling in some
Propanoic acid.
Until we've used up all the NaOH. And what I want to know is how much of this am I going to need to add in grams? Okay, so let's go here. We actually have 2 places we could start because we have 2 pieces of information already, don't we? Nope, not a limiting reagent. What's our volume? So we could start here if we wanted, but we also know what? We're going to need the molar mass. We'll get there. We know the concentration, so we could start there. It doesn't actually matter where we start. But I have a rule, I don't know if last check always taught this, but if I'm doing dimensional analysis, I just look at what's my answer. Where am I going? Where am I going here? What do I want to know? Mass. And do I want to know the mass of sodium hydroxide? No, I want to know the mass of propanoic acid. So the question is, we've got to start at one of these and make our way down there. A little roadmap, right? Well, you could start at either one, but I've always found it a little helpful to say, what's the unit of my answer going to be? In this case, it's grams. Is that a fraction? No. So when I choose which one of these to start, if I start with a fraction, then I'm going to have to unfraction it. Does that make sense? I'm going to have to think about, how do I get this to not be a fraction? Does that make sense? That's stressful. So I've always said if your answer is not a fraction, start with the number that is not a fraction. So let's just do this. Let's just say what's our volume? We're going to go from volume down to grams. So what am I going to have to do? I'm going to have to convert volume to what? Number of moles. Then from number of moles, I'm going to convert that to what? I'm trying to get here to... Yeah, so I'm going to go from moles of NaOH down to moles of propanoic acid, right? And then from moles of propanoic acid, where am I going to go? To grams of propanoic acid. Does that make sense? That's our roadmap. From liters to moles, from moles to moles, from moles to grams. How do I go from liters of solution to moles of that stuff? What do I need to know? Do I know that? Yeah. Beautiful. And then to go from moles of one thing to moles of something else, what do I need? Balanced equation. Is this a balanced equation? Does it work? Yep. Does one of those react with one of those to give us water? Yeah, this has 1 hydrogen that it can give away. This has 1 OH. So we're good. We've got a balanced equation. And then the last thing we need is to go from moles of one thing to grams of something else. And we're going to need a molar mass of this. So I like to kind of find that in advance if I can. Saves me effort, right? So we need the molar mass of what? The propanoic acid? Oh, whoa, oh, wow. Okay, slow down. Though, you're right. Good job. What is the molar mass of C3H6O2? Well, what's it made of? 3 carbons. How much does each carbon weigh? 12.011 grams per mole, right? And then we're going to add to that how many hydrogens?
6.
And what do they weigh each?
1.8.
Yeah, good. And then we're adding to that what?
Oxygen 2 and 2.
And they weigh what? 15.9994? Okay, so if we take a minute and do that just on your calculator, I'll do it here together. Let's do it all together. Have you missed this? Did you wake up today think, you know what I'm really looking forward to today? Some stoichiometry. So 3 times 12.011, then what? 0.079 plus. Great, and that gives us 74.0792, which I think is exactly what you said. Yeah, don't worry about the rounding. That's obviously way more sig figs than we're going to need, right? In fact, it's probably more sig figs than we even can really give ourselves from this, but that's okay. We're not going to worry about it because it's not our final answer. For our final answer, we'd worry about sig figs. We're just going to keep the extras for now. Okay, so let's get going. We said that the easiest place is going to be to start with the non-fraction unit, so we're going to start with our volume. What is our volume? 0.500 liters. Love it. Okay. And now when we do dimensional analysis, what should I do right away? Multiply by? Yep, but first I want to just really break it down. Multiply by a line, right? And then we say, what unit don't we want to talk about? Liters. Okay, if I don't want to talk about it, what should I do with it? Yep, and just slow down for me, okay? Slow your roll. I want to make sure everyone gets a chance to get there, okay? Slow down. Yeah, I don't want to talk about liters, so we're going to put it on the bottom. Okay, good. Now, eventually I want to talk about grams of this other stuff, but if we look here, in this one step, what am I going to talk about instead? We're going to stop talking about liters, and instead we're going to talk about moles. So where does that go? On the top. Now we need, and by the way, moles of what? Well, we're talking about NaOH. So how many moles of NaOH are in a liter of this stuff? Well, now, do we have that information? Do we know how many moles are in a liter? Or how many liters are in a mole for sodium hydroxide in this case? Slow. Let's look at the question. Do we have something that tells us how much sodium hydroxide is in a liter of solution? The concentration. And what's our concentration? 0.75 molar, and molar means how many moles are in a liter. So how do I put that into here? If you're not sure where the number goes, if I put it here, what does that say? That there's 0.75 liters in. Is that true? No. So where's the 0.75 go? On top. Awesome. And how many liters is that? That's 0.75 moles in 1 liter. Does that make sense? Per liter means per 1. What units cancel? If I were to do this calculation now, what would I know? How many moles of NaOH I started with? But is that what I want to do? No. So what do I do? Multiply by another fraction. Now, nice and slow. What's our next step? We don't want to talk about moles of sodium hydroxide. The question asked about propanoic acid, right? So how do I go from moles of one thing to moles of something else? I look at balanced equation. So what don't I want to talk about?
The moles of sodium hydroxide.
Good. Where do I put it? Slow. I don't want instant answers. I always want a little pause so people can think. All right? If you get an instant answer, that means you've got it. That's great. I love that. I love that you have it. But that doesn't necessarily mean everyone in the room has it, right? So just slow your roll. All right. We don't want to talk about moles of NaOH. So where does it live? On the bottom. Good. Now, and again, slowly, what do we want to talk about? Yeah, very good. So we're going to put that up here. And I'm just going to put PA for propanoic acid. Everyone cool with that? Rather than writing the whole thing out? All right. Now we have our units, but we need to put numbers in there. This is a nice, simple stoichiometry. How does this reaction work? 1 to 1 to 1. Everyone see that? So you need one of these and one of those, and it gives you one of the other. 1 propanoic acid reacts with 1 sodium hydroxide to make 1 water molecule. So that's a nice, easy stoichiometry. What units cancel? Moles of sodium hydroxide. If I were to stop calculating now, what would I know? How many moles of propanoic acid I'm going to need. But of course, can I go in the back and get out a bottle of propanoic acid and get a scale and weigh out moles? No, because moles isn't a mass, it's a counting unit. Am I going to sit back and count out individual propanoic acid atoms? No. right? So I need to convert it to grams. So what unit don't I want to talk about? I'm going to throw my glasses at you. Slow down. Slow down. I want an air gap between my question and any answer, all right? Slow your roll. Yeah, what unit don't I want to talk about? Reach right for the teacup. That was aggressive. Yeah, I don't want to talk about moles of propanoic acid. So, look at me. Look at my face, Kate Audette. Shh. So where do I put moles of propanoic acid? Quiet. Where do I put it? Yeah, what do you think? We put it at the bottom, all right? And then, all right, Kate, your moment to shine. What do I put on top?
The grams.
Grams, and of what?
Propanoic acid.
That's right. You can only go from moles of one thing to grams of that same thing, right? And where do we look for that information? Periodic table. Now, luckily, what have we already done? We've worked it out. And what is it? Cool. Got it. What do you mean no?
No, it goes on top.
As I appear to be a chemistry teacher, I don't know if you notice, I have a degree.
You want to find it, so it goes on top.
I want to find it. Well, I want to find one.
You want to find the grams, so it goes on top.
I did put grams on top. 1
No,
gram of
it's not
propanoic acid is
grams.
74.08 moles
No,
of propanoic acid.
The number is the grams.
Yeah, good. Right? You have to always make sure it's going where it goes. And I'm going to round that to 0.08 because that's plenty. And what number goes down here? 1, because the periodic table doesn't know what question you're doing. All right, what unit cancels? Moles of propanoic acid. And so we're going to now find out how many grams of propanoic acid we have. Now listen, if this feels like you, because I know a lot of you just did 3U Chem, which is why some of us can just hypothetically sit right at the front of the classroom and answer every question like instantaneously. But I actually seriously need you to slow down when we're doing stuff like this, because remember that some of these people haven't done this stuff in over a year, right? So it's not on instant recall for them, right? So we gotta slow down and let people have a chance to think. Can we do this math? What do I type in? Help me out. Yep. Yep. Yeah, and listen, I'm going to do the dividing by 1, and I know that that doesn't actually change the number, but I'm still going to do it. I'm going to do every step here. Times 1, divide by 1, times 74.08, divide by 1, and that's going to give us an answer, 27.78. And what's that unit? Okay, but let's, of course, be careful. How many sig figs we dealing with here? 3 sig figs, agreed. How many here? 2. How many down here?
That's indefinite.
That's right. Yeah, infinite's counting, right? How many here? Infinite, counting an equation, right? Infinite. How many we got here? As I wrote it. 4. All right. And this is? Yeah, infinite. And so how many sig figs do I get? 2. So the answer is 27. Oh, 27 grams. Of course, I need units. Grams of propanoic acid. Why am I rounding it up? Yeah, good. All right, very good. So the answer then is that if we have a 0.5 liter solution of 0.75 molar sodium hydroxide, 28 grams of propanoic acid should work. Now listen, I'm going to hit you from time to time with some stoichiometry and some grade 11 stuff, because you don't want to get to university and it's been 3 years since you've done stoichiometry, all right? You want to have it nice and fresh. You want to have it at recall, all right? There's some practice on here. The practice on this page actually isn't carboxylic acids. What are these? Alcohols. The next page, what are these? Ketones, right? And some aldehydes. So I've also got a sheet here that's got some practice of carboxylic acids for you, all right? And I encourage you to do that as well. We'll walk around and help you out. Use your time. If you want to build models because you have to finish that for tomorrow, you can do that as well. Here you go. Get to it. Just come grab one.
Whoa, I'm dying.
Kate, you're doing fantastic, by the way. So I hope you don't feel like I'm picking on you or giving you a hard time. You're doing great, but seriously, just do remember, some people in this have been a long time since they've had to do stoichiometry, so you gotta give them some time to think, all right, dude? Cool. But you're rocking it.
I don't know why I found it so hard when I just did it now and it's the easiest thing ever. I think I'm just.
Because you're older and wiser.
I don't know why.
Older and wiser. Older, wiser. Yeah.
When you say include a photograph, do you want us to build like both of them, the cis and the trans isomer, and take a like picture of them?
Yes, for that one I want a picture of the cis and I want a picture of the trans.
Like build them with a model kit.
Yeah, and it's a quick change. right? Like it's literally just. Have you looked up what those words mean yet?
Well, I looked at stereoisomers,
Yeah.
and then in the little like diagram, it had like a little tree thing, and one of them was like the cis and the trans.
And did it make sense to you?
To me, I just the picture and like the group, like what they are.
Because yeah,
so
like if I can.
it just looks like you took like the OH on top of one and you stuck it on the bottom instead.
Yeah. So let's say we had dichloro ethene, right? 1,2-dichloroethene. You could either draw it like this, because as soon as you have a double bond, this can't freely rotate, right? So it could look like that, or it could look like this, right? Did I do that? Those are different, right? Okay, good. They're different, right? And these aren't the same thing. Does that make sense? Like that isn't, you can't rotate this to get that. So the cis and trans naming, this used to be really hard for people because they didn't know what those prefixes mean, and now everyone knows what those prefixes mean. Yes! Oh, nailed it. Yes, exactly. We call this trans because they're on different sides, right? They cross across, right? And we call this cis because they're on the same side. Yep. So that is, and again, it's so funny because 10 years ago you teach this and people would be like kiss and you're like, no, cis, and like nobody ever heard those terms before. And now, easiest lesson I teach.
You're good with the setup?
Yeah. Yeah, I'll head down there just a couple of minutes, but it should be good to go. What device are you playing the music from? Your phone? Okay, so that's the easiest thing of all. Can I come down in 5 and just Bluetooth pair you to the stuff?
Yeah, just as long as we're playing music as the bell goes.
Yeah. Yeah. Sorry? Do I have anything marked? Let's see if it's in my marked file. You got your test back, right? And then... yeah. Yeah. Ruby. Matthew. Aruba. Also Aruba. And Jordan. Yes, you are. There you go. Fun. Sorry?
You were shaking there. Your hand was.
Leave my hands alone, thank you. There you go. There you go, Aruba.
Well, it was a 99.
Is that a 6?
But this has to
Yeah.
Okay, I got 100. Same thing. Yeah.
You know you can check your mark online now, right, too? I put back up the check your mark guy, and she works.
I didn't know because
Yeah, it's up and running.
I didn't get the assignment.
Okay, go check the big pile of awful papers. It'll be on this one. It's under the mittens. You're welcome. Yeah, I printed them as to where they are. They're in the pile that Calford brought down to me of stuff that was in the jam photocopiers. So yeah, they should be right there. Yeah, there you go. There's 2 of each. So you can see.
Oh, we printed them out. You just gotta ask for
Big pile.
Exactly what it's at.
And here's today's work, guys. Grab a copy. Speaking. Oh, what I will find it. Oh gosh, I think that's too hard.
Is it okay if I go back to work on my last model?
Yeah, you bet. Why are the Hello Panda chocolates on my... Also, like, how long do they have to be there before I can just eat those and not feel guilty?
Such a good student.
Is it possible for them to not have like?
Yes.
Yeah.
Yep.
Because I was looking at that and I was like,
Yep, there will be no sister trans for that because it's when there's a sub, like if that F were here, then yes, there'd be a sister trans version, but not where it is there.
So for the photos, I just need to put in the first.
Actually, you might still have a system trans. Let me see your structure. Let me think. No, you won't, because there's no. Yeah. If you had a, you're good.
I only have one.
Yeah. I'm not a good 3D thinker, so it always takes me a minute. We'll talk about it. You need to have something called a chiral center to have a system trans isomer. Sorry? Who does? Oh, good.
I tried helping him, but like I'm blinking.
Is it like?
Oh, right.
Wait, like
It's like
quadratics?
yes. It's like the fencing one. Like the style of fence is this.
Quiet. 1 sec. Oh, shoot. Oh, I'm gonna be. Oh, that's unfortunate. Oh, man. Oh, shit.
Like this. Like it'll be like, oh, what's the highest perimeter you can use or something.
Oh, I never understood radicals. Okay.
Radicals are obnoxious, eh?
Quadratic, standard,
Everything when you know what.
1 sec. Sorry.
Is it gonna like determine if this is a function or not?
Was that unit 1? Yeah. Oh. Unit 2?
Can you do me a favor and quickly? I've got to go get Ventnor set up, and I got to be back for. I mean, can you quickly just give Tanner a pointer in the right direction? Work on some math on that. It's simple stuff. Just I promise, we're not going to find it confusing. Point in the right direction. And they'll be right back. Hang out, Mr. Ventnor, or something.
Is it gonna ask like a mapping test?
I think.
You think?
Bro, I'm we do have to.
And the test do we get them from this place long quadratic form. U square plus minus square root of something. Yeah, do we like do we get it in the test? We have to know.
So wait, if it will be like a question that's like, oh, determine how many weeks.
Yeah, I'm asking that.
You have to memorize the
that.
formula.
I said online. Do you have to know that like
True.
do I have
Like,
to know
no.
it? Like you just give me the formula.
Well, it does say at least. It doesn't say like.
If you don't want me knowing. Okay.
Yeah, and you can tell me.
Excuse the interruption, everybody. If we could have the student council come down to the main foyer for our lunchtime event. Happy Leap Day, everybody. Something special for you in the library. Student council members down to the front foyer at this time. Thank you very much. Bye now.
What? For carbon?
Is it gonna ask for the
There you go. It's now campus for carbon. I mean, it is basic as hell because we're just taking a butane, but it works.
Oh, it's so cute.
It's like a little. I think if it's the one with no like double bond, where it's just like the carbon and hydrogen in single bonds.
Are we questions? You have questions? Yeah.
I'm not really sure.
First of all, what kind of
That is a very broad effort.
well, is it in the It's like you have several different organic compounds, right? Do you know all organic compounds that you have so far? Can you name them? So like you have alcohol. Alright, so first we gotta figure out what you're looking at. And a good way to help you is by looking at your function. You know what function is? It's like the lesson.
No, I don't know.
You have your nose. Okay. That might help.
You can do more if you want. Carbon that makes four bonds.
No. So like I think you're on the right path.
Wait, one that has like a straight chain. Oh yeah.
And what's
This I don't know.
single bond? Oh, yeah. You only have single bonds and no double
It
bonds.
works
triple
though,
bonds,
in
no
theory it
functional
does.
groups. That's an alkane. Okay.
Relation.
What's an alkene?
No, it works in theory, that's all that matters. If push comes to shove, I'll withdraw it.
Oh my gosh.
So,
It's the one that.
I moved over.
It has.
So it doesn't matter if it's like a double bond or
Four bonds?
Excuse the interruption. This is just a reminder that the first prom committee meeting is being held at lunch in Mr. Orlando's room room 80. Thank you.
So alkanes is just straight chain carbons, only single bonds. An alkene is when you have a double bond. And then an alkyne is when you have a triple bond. Okay? Then we can also add some functions. So you have like the halides, which make up like they are the halogens of the periodic table. So if you have any like halogens attached to your organic compound, that's the halide. And then you can have also other groups attached to the mass OH. That's the hydroxide. We have OH, what does that mean?
Oh wait, no, you need to do more.
It's an alcohol, right? When you have OH,
Oh.
you have an alcohol. How about when you have a double bonded alcohol? I don't like that. I don't like that smell. Actually, I love it. Well, carboxylic acid is double bond O with OH. So this is a carboxylic acid, but it is just double bond O. There was no OH attached. That's a lot. What do you call it? Okay.
Ketone is like a double bond.
I think it was yesterday.
He said this to me.
Okay, I can review the lesson and make sure you know what
That was the
solve.
one thing.
But then once you know that, it will
Like, it's the most important thing here.
Why did we send that to her? Yeah, like look at this.
Oh, wow.
Oh my god, I wanted this dude. Oh my god, this dude.
Your relation is like
No, this is wrong. And I got
Relation
that.
just means like,
okay, so no,
I mean, yeah, you
don't
we
do
talk
it.
about
What's an
the
alcohol
language,
verb?
like, here.
Just saying been that a thing. Mine has just been that for forever because she hasn't sent me recently.
Excuse the interruption, folks. On today's cafeteria menu, we have chicken vegetable soup, assorted sandwiches, freshly made subs, Caesar salad, and burgers with fries, and an option to add either cheese or bacon for just $1 each. Thanks for listening. Have a great day, Eagles.
So aldehyde is the other way. Aldehyde is when
I mean, yeah, I didn't have to get it.
double bond on the term. And then last order. Okay? So that's another. So this should be an 8.
I'm sure one of
Alright. Yeah, so these are examples of
physics.
ketones are when you have a double bonded O in one of the middle slightly. So here, you have the double bond on the middle part, not on the first side. Right, when it's on the first or last, that's a ketone trimer.
18 girl, 18.
Now it's actually when it's on one of the middle parts, it's a every compound has a so like
When you say compounds, you mean like
yeah, like okay, so when you have oh, and the last one don't have it.
Yeah, I was wondering if you had that. Yeah, I messaged you. I didn't answer your
On one side.
so bad.
I thought you were laughing like I kind of like something after that.
No, what did I do? No, I'm just trying to figure out who took those photos. Because I have a bunch of photos of it, but I didn't have any.
My debit card's gone.
Let's see how much money they may have to see a picture of
I want to see the boy pulled last night.
So when you put them together, you get a okay?
I hope not.
These are like
Oh, really? I'm sorry, Ruby. Sorry, Ruby. Can you just kind of assume anything weird?
I did. I used it was so bad.
You get any more, to be honest.
What?
Really tell me that.
Oh my god. Sorry. He's listening to me. My apologies.
Be kind. Kindness, Charlie. Sorry? No, you're not.
At least I'm not saying it. What are you holding?
That is obviously worse. You know that, right? You understand that, right? That there's at least a certain degree of bravery required to say things to people's faces, but there's actually no bravery required whatsoever to moan and complain about people when they're not around.
Why would I walk up to the face like you're annoying me and just walk away?
Well, the answer to that question is if you wouldn't, then why would you say it when they're not there? Right?
Because I'm expressing my anger
Why?
to get over it. Stop.
I think you will find that that actually has the opposite effect. Yeah. No, don't be petty. You don't be small. Small people talk about other people.
Do you think it has a?
Can I tell you? You don't want to do that. You don't want to do that. Well, I'll tell you why. Because the cyclo of it all is fine. You can work with the cyclo, but then you don't want to start putting stuff on your side chains. Can I tell you why? Because we haven't even talked about that naming yet. How do you name it when you now have substituents on a side? Because this is a cyclo 1, 2, 3, 4, 5. So this is a cyclopentene, right? Sorry? Yeah, no, this is a methyl group. That's a methyl group. That's a methyl group. And then what is this? This is a chloromethyl group. That's bad enough. Now what is this? This is a 1, 2, 3. This is a propene.
I know why she did that.
But you know what I'm saying? So do you want my honest advice? Just do that. Dude, do yourself a favor. Put a hydrogen there. Put a hydrogen there. Avoid the cyclo of it all. You're going to be a much happier person, all right? All right? I appreciate your commitment. And even then, don't put this here. Don't put this on your side chain. Just for now, do yourself some favors, and we'll do this. Hydrogen lives there. And is this a chlorine? That's what we're calling that? Yeah, perfect. Do that. You'll have a much easier go of it. You don't have to make your life too hard, all right? Howdy.
So we don't
We don't connect this.
Like you can, it's a real structure, but we haven't talked about how to name those yet, so I wouldn't. But you can. It's real. Like if you can build it, it's real. But it's gonna make your life harder.
Not really about something else.
Yeah.
But
What's
thank
up?
you.
What's up, Kiki?
I'm not like expected to be able to know answers off the top of my head
No.
like that, right?
No, that's why I'm trying to slow her down. The exact opposite. When I ask that, I'm not looking for the answer. I don't care about the answer. I'm going to tell you the answer. I'm going to write it on the board. When I'm talking, and this is why I love and adore Kate. I got to slow her down a little because it's not about the answer. What I want you to do is start going, oh yeah, I wonder what that is, and I want you to think about it, and then I want to like walk us through it. So no, don't. Learning isn't having the answer on top of your head. That just means you already know it. Learning is getting to the answer. So what I'm trying to do when I ask questions like that is have like a nice pregnant pause where we then think about it and then we go like, yeah, let's work that out. No, you don't feel like you're supposed to have the answer like that. You're not supposed to have the answer like that. If everyone had the answer like that, I wouldn't have a job. Then you'd all know chemistry, right?
Yeah.
So no, you're good. You're doing great.
I have one more question.
Yeah,
so
please.
the assignment that the class started yesterday is due tomorrow, right?
Yeah, you'll have some time tomorrow.
Is it like if I don't finish it, can I stay after school and finish it?
Yep, 100%. Yep, absolutely.
Thank you.
No problem. Sorry? Well, we'll find out. Welcome to prom committee. It's basically how it works.